Top 20 Python Data Analyst Interview Questions and Answers. Want to land your next data analyst role using Python? In this video, we break down the top 20 Python Data Analyst Interview Questions and Answers, perfect for impressing recruiters and showcasing your skills. 1. How have you used Python in your data analysis projects? I've used Python extensively for data wrangling, exploration, visualization, and statistical analysis. In one project, I automated data collection from APIs using requests, cleaned and transformed the data with Pandas, and analyzed customer behavior patterns. I applied machine learning models using scikit-learn to forecast trends. Python's flexibility allowed me to write reusable functions and handle large datasets efficiently. I also created visualizations using Matplotlib and Seaborn to present insights to stakeholders. Python's wide ecosystem of libraries has made it my go-to tool for end-to-end data analysis and storytelling. 2. What Python libraries do you commonly use for data analysis and why? My go-to Python libraries are Pandas for data manipulation, NumPy for numerical operations, Matplotlib and Seaborn for visualization, and scikit-learn for basic machine learning tasks. I use Pandas to filter, clean, and reshape datasets efficiently. NumPy helps with fast array calculations and is essential for vectorized operations. For insights presentation, Matplotlib and Seaborn provide rich, customizable plotting capabilities. I also use stats models for statistical testing and OpenPixel or XLRD for Excel integration. These libraries offer high performance, scalability, and wide support, making Python a powerful tool in my data analyst toolkit. 3. Can you explain the difference between a list, tuple, and dictionary in Python? A list is a mutable, ordered collection of items, meaning its contents can be changed after creation. A tuple is similar to a list but immutable, making it more memory efficient and suitable for fixed data. A dictionary is an unordered collection of key-value pairs, allowing fast lookups based on unique keys. I use lists when I need dynamic data manipulation, tuples when data integrity is crucial, and dictionaries for structured, associative data like configuration settings or record mappings. Understanding these structures helps optimize code readability, efficiency, and functionality in data-driven applications. 4. How do you handle missing data in a dataset using Python? I handle missing data using Pandas methods like .asnull, .filna, and .dropna. First, I assess the extent and pattern of missingness. If data is missing at random and minimal, I may drop those rows. If values are critical or sparse, I use imputation techniques, mean, median, mode, or even interpolation. For categorical variables, I might replace nulls with unknown or the most frequent category. I also ensure transparency by documenting changes. These strategies preserve data integrity and enable effective modeling, as handling missing data correctly is essential for unbiased, accurate analysis. 5. Describe a project where you used Pandas for data manipulation. In a customer segmentation project, I used Pandas to clean and transform transactional data from multiple sources. I merged datasets using merge, parsed timestamps into date-time formats, and created new columns to track purchase frequency and recency. I used GroupB to aggregate customer-level metrics and applied filters to identify high-value segments. Data was normalized and pivoted for final reporting. Pandas provided powerful capabilities to reshape, sort, and analyze data efficiently. The final output was used to tailor marketing strategies and improve retention. The project showcased how Pandas streamlines complex data tasks. 6. How do you perform data cleaning in Python? I use Pandas extensively for data cleaning. I begin by inspecting the dataset for missing values, duplicates, and incorrect formats using .info, .asnull, and .duplicated. I handle missing data with .filna or .dropna based on context. For inconsistent data, I apply string functions like .strlower or .replace to standardize text. I correct data types using .astype and filter out outliers with statistical thresholds. Regular expressions help in parsing complex fields. I validate changes using summary statistics and ensure the clean dataset is ready for analysis or modeling. Clean data ensures reliability and actionable insights. 7. What are some common functions in NumPy you use for numerical analysis? I frequently use NumPy functions like np.mean, np.median, np.std, and np.percentile for basic statistics. For mathematical operations, I use np.sum, np.exp, np.log, and np.sqrt. Array manipulation methods like reshape, flatten, concatenate, and broadcasting techniques help optimize performance. I also rely on logical indexing for filtering arrays efficiently. NumPy's ability to perform vectorized operations makes it significantly faster than Python loops. These functions are critical when performing large-scale numerical computations and are often used as a foundation for data preprocessing, statistical modeling, and building complex analytical workflows. 8. Explain how you would merge or join datasets in Pandas. In Pandas, I use the merge function to join datasets based on common keys, similar to SQL joins. For example, I might use pd-merge, df1, df2, on equals id, how equals inner, for an inner join, or how equals left, for a left join. I ensure the key columns are of the same data type and handle duplicate keys with care. 4. Concatenating datasets vertically or horizontally. I use pd-concat. When merging on indexes, join is useful. Merging is a critical task when combining multiple data sources, and Pandas makes it flexible and intuitive. 9. What's the difference between .lock and .ilock in Pandas? .lock is label-based indexing, meaning it selects data by row or column labels. For example, df.lock2 name fetches the value in the row with label 2 and column name. .ilock is integer position-based indexing, such as df.ilock2, 1, which selects the item in the third row and second column. .lock is ideal when working with named indexes, while .ilock is helpful for programmatic access based on position. Understanding the difference is crucial for accurate slicing, filtering, and subsetting, especially when dealing with mixed data types or reindexed data frames. 10. How do you visualize data using Python? I visualize data using libraries like matplotlib, seaborn, and plotly. For quick plotting, I use matplotlib.pyplot to generate line plots, histograms, and bar charts. Seaborn helps create more advanced visuals like heat maps, box plots, and violin plots with built-in themes and statistical support. I also use Plotly or Altair for interactive dashboards, which are ideal for presentations. Before plotting, I clean and aggregate data as needed. Visualization helps communicate insights clearly and supports data-driven decisions. Python's ecosystem offers flexibility to create publication quality or interactive visuals tailored to any audience. 11. Which Python libraries do you prefer for data visualization and why? I prefer Seaborn for its beautiful and informative statistical plots, and Matplotlib for complete control over visual elements. Seaborn simplifies creating heat maps, bar plots, and box plots with less code and integrates seamlessly with Pandas data frames. I use Matplotlib when I need custom plots or to fine-tune visuals. For interactive visualizations, I use Plotly and Altair, especially when building dashboards or web-based reports. Each library has its strengths, and I choose based on the complexity and audience. Effective visualization is crucial for communicating insights clearly and supporting strategic decision-making. 12. How do you use Python to perform statistical analysis? I use sippy.stats and stats models for statistical analysis in Python. I start with exploratory analysis using descriptive statistics, mean, std, describe, via Pandas or NumPy. For hypothesis testing, I use t-tests chi-square or ANOVA with sippy.stats. I use stats models for linear regression, time series analysis, and detailed statistical summaries. These tools help identify relationships, test assumptions, and model trends. I ensure data is cleaned and assumptions are checked before applying any test. Python makes it easy to automate and repeat statistical analysis, ensuring accuracy, scalability, and reproducibility across projects. 13. Describe how you've used Python to automate a data-related task. In a previous role, I automated a daily sales reporting task using Python. I wrote a script to extract raw data from CSV files and a company database, clean and aggregate it using Pandas, and then generate Excel reports with charts using OpenPixel. The script ran on a schedule using cron or Task Scheduler on Windows, sending the final report via email with some plib. This automation saved hours of manual work and ensured consistent, error-free reporting. Automating repetitive tasks with Python boosts efficiency and allows analysts to focus on more strategic analysis and insights. 14. What is the purpose of GroupB? In Pandas, the GroupB function in Pandas is used to split data into groups based on one or more keys and apply aggregation or transformation functions. For example, you can group sales data by region and calculate total revenue using df.groupb, region, revenue.sum. This function is powerful for summarizing, transforming, and analyzing large datasets. It enables efficient computation of metrics like averages, counts, and medians across categories. I use GroupB extensively in customer segmentation, performance analysis, and trend identification. Mastery of GroupB is essential for unlocking valuable insights from structured data. 15. How do you handle large datasets that don't fit into memory? When dealing with large datasets, I use chunking in Pandas with read_CSV by specifying the chunk size parameter to load data in manageable parts. I process each chunk iteratively and store intermediate results before combining them. For performance, I might use Dask, a parallel computing library that extends Pandas for out-of-memory operations. I also consider optimizing data types to reduce memory usage and storing preprocessed data in binary formats like Parquet or HDF5. For extremely large data, I integrate Python with SQL or cloud-based platforms. Efficient handling ensures scalability without compromising accuracy. 16. Can you write a simple Python function to calculate the mean of a list? Yes. Here's a basic function. Python, copy edit, def calculate _mean data. Return some data /len data if data else 0. This function first checks if the list is not empty to avoid division by 0. Then it calculates the mean by dividing the sum of elements by the count. In practice, I'd also validate data types and consider using NumPy for efficiency on large arrays. np.mean data. This showcases both an understanding of Python basics and the importance of error handling in real-world data analysis. 17. How do you optimize Python code for performance in data analysis? I optimize performance by using vectorized operations with NumPy or Pandas instead of loops. I avoid unnecessary copies of large data frames and convert data types to more memory-efficient formats, e.g., int8 instead of int64. I profile code using tools like cprofile or line_profiler to identify bottlenecks. When needed, I use multiprocessing or parallel computing with joblib or Dask. I also reduce I/O operations by storing intermediate results in memory-efficient formats. Optimization ensures scalability, especially when working with real-time analytics or large-scale datasets. 18. What's your experience with Jupyter Notebooks or similar tools? I use Jupyter Notebooks for exploratory data analysis, prototyping, and presenting findings. Its interactive format lets me combine code, visualizations, and markdown explanations in a single document, making it ideal for storytelling and sharing insights with stakeholders. I structure notebooks with clear headings, inline comments, and visual outputs for clarity. I've also used JupyterLab for more advanced workflows involving multiple notebooks and terminals. Version control is handled via exporting to .py or integrating with Git. Jupyter enhances transparency and reproducibility, especially in collaborative data science projects. 19. How do you document your Python code for reproducibility? I ensure reproducibility by writing clear, well-commented code and using consistent naming conventions. Each function includes a docstring that explains its purpose, inputs, outputs, and assumptions. I use Jupyter Notebooks with Markdown to document workflows step by step. For larger projects, I maintain README files, configuration files, and requirements.txt for dependencies. I often set random seeds for deterministic outputs and log versions of data sources and libraries used. Good documentation allows others to understand, audit, and replicate the analysis, which is essential in professional data environments. 20. How do you validate the accuracy and integrity of your Python-based analysis? I validate accuracy by cross-checking results with known benchmarks, applying sanity checks, and reviewing statistical summaries. I use unit tests to verify function outputs and test against edge cases. Data validation steps include checking data types, value ranges, and consistency between sources. I also review outputs visually using plots and confirm that trends make logical sense. Peer reviews and feedback from domain experts further ensure reliability. Maintaining a structured, testable, and documented pipeline allows me to detect and correct errors early, ensuring the integrity of the entire analysis. Thanks for watching the top 20 Python Data Analyst interview questions and answers. If you found this helpful, give it a like, drop your questions in the comments, and subscribe for more data career tips. Your Python-powered future starts now.